Okay, what we have here on the top of page 23 is more application of taking the derivative. So the first question that I'm looking at is example 4, and it says find the equation of the line that is tangent to the given graph at this given point. So if I want to find an equation of a line that's tangent to the graph, I need to remember y minus y sub 1 is equal to m times x minus x sub 1. Okay, and I'm going to take the derivative of this so that I can find the slope, which would correlate to this line that I'm looking for at this given point. So the other thing I need to do is also find my y value. So y is equal to the secant of pi over 3, which is the reciprocal of the cosine of pi over 3. So this is at 60 degrees. So the cosine of 60 is 1/2. So that means that the secant of pi over 3, which is the same thing as 60 degrees, is 2. So what you have is a point pi over 3, 2. This is my point, and I'll need this for later. So now I need to find the derivative. Y prime of the secant of x is secant x tangent x. Okay, so that's the derivative, and I'm going to use the derivative to find the slope at pi over 3. So I'm evaluating y prime of pi over 3, which would be the secant of pi over 3 tangent of pi over 3. So the secant of pi over 3 we already figured out is 2. The tangent of pi over 3 is the square root of 3. So this is my slope because this is the derivative at pi over 3. So that's the slope, which is what I need for right here. Okay, so I have my points, or my coordinates, and I have my slope. I can write the equation of the line. So this is y minus 2 is equal to 2 square root of 3 times x minus pi over 3. That's the equation of the line that's tangent to this curve at pi over 3. Okay, in example 5, it says find all x values in the given interval at which the graph of f of x is equal to x minus the sine of x, and it has a horizontal tangent line. So we've already talked about this, so I'm not going to go through this problem, but if you look on the notes, it's pretty specific. But basically what I want to do is find the derivative and set the derivative equal to 0 because I have a horizontal tangent line, and I know horizontal tangent lines have slopes of 0. Okay, in this last example, this is actually where we are taking all of this information, and this relates to physics. So what we're talking about is a particle or some type of bug or something that is moving along a line or a position axis at a given time. Okay, and when we are taking a look at using the derivative, what we're looking at is when we take the derivative, we're looking at the velocity of this given particle or bug or whatever we're talking about at a given time. The relationship of velocity and speed is that speed is the absolute value of velocity. So what you need to remember is that speed is not affected by direction. Therefore, speed cannot be negative. You might want to make note of that. It's a reminder. If you get a negative value, you forgot to take the absolute value. And then we'll find all values of t, if any, meaning at what times the particle is at rest. And what this means right here is that the velocity is equal to 0. Okay? So the first thing we want to do is we're given our function, and it's up here at the top in the actual example. This right here means that I cannot give any other answers if they fall outside of 0 to 2 pi. So here's my position function, and in order to find the velocity at time t, this is just very generic. This means that they want the standard or just general form of the equation that is the derivative. So the velocity is the derivative of the position function. So I'm going to take the derivative of this. So the derivative of t is 1. And the derivative of the cosine is negative sine, so this is minus 2 sine of t. Okay, now this doesn't say at time 1 or 5 or whatever, so this is all they care about. They just want this. This is the velocity function. Okay? Now that we have the velocity function, we can find the speed at time pi over 2. So what this means is speed is equal to the absolute value of 1 minus 2 sine of t, okay? And they want us to evaluate that at pi over 2. So what we want to do is take the absolute value of our velocity evaluated at pi over 2. That's all this is saying. So these two are the same. This one's at a specific value. This is just general. So I'm going to plug in pi over 2. We have the absolute value of 1 minus 2 sine of pi over 2. Okay, the sine of pi over 2 is 1, okay, because it's up at 90 degrees. So this is 1 minus 2 times 1. So this is the absolute value of -1, which means this is 1 meter per second, because they did give us our units of measurement here. So you need to make sure that you answer with the appropriate label. Okay, so this is the general velocity function by taking the derivative of the position. This is the speed, where we have evaluated our velocity at pi over 2 and we take the absolute value. That's the relationship. And now it says find all values of t, if any, for which the particle is at rest, meaning our velocity function is equal to 0. Remember, you have a time frame here from 0 to 2 pi. Okay, so what we're going to do is go back in our minds to pre-calc when we had to solve trig equations. 1 minus 2 sine of t is equal to 0. So I'm going to add this over here. So I have positive, divide by 2. And now you need to ask yourself, on the unit circle, between 0 and 2 pi, what angle or angles do I take the sine of to get 1/2? So you got to think. Here is these are my 4 quadrants. Sine is positive here and here. So you need to think what those angles are. And more specifically, you need to think in terms of radians, because that's how it's given. So your time frame is pi over 6 and 5 pi over 6.